All right, thanks for watching. Welcome back. We're going to solve this video. If you haven't watched the first one called the washer method, I would go ahead and do that. We're going to be doing the same problem here. We've got this region here. I'll shade it in green. We're going to take that and we're going to revolve it around the y-axis. We're going to do that revolution. And in this video, we're going to use the shell method. And remember, with the shell method, our strips are going to be perpendicular. Are going to be parallel. They're definitely going to be parallel to our axis of revolution. So our axis of revolution is this y-axis, and so our strips are going to be parallel like this. And so what I'm going to do is I'm going to imagine what happens if I take one of those strips and I revolve it around the axis. I'll try to make it quite bold. If I revolve that strip around, what am I going to get? I'm actually going to get a cylinder. It's kind of hard to draw on this iPad, but if you take that green strip and you revolve it, we're going to get a cylindrical shell. And if we think about that shell, the area of that shell is going to equal 2 pi times the radius, is the radius of that shell, times the height. And so if I think about this one here, let's kind of zoom in and look at this shell in particular. Well, if this is x, then I can give you an exact formula for the height of this, for the length of this, right? So the height of this thing is just going to be equal to the y value. Right, and so this is y equals x squared plus 1. And so my height is going to equal x squared plus 1. And my radius, well, again, if I revolve this thing around, that radius is going to be the distance to my axis. So that radius, maybe I'll do it in blue, the radius is going to be this distance here. So that radius is going to be the x value in this case, because that's just going to be the distance from the axis out to x. And so when I put all this together, to get the volume by the shell method, I need to add up all those little areas. So I'm going to be integrating with respect to x, and x is ranging from 0 to 2. And I want to do 2 pi r times that height. Right? And now I just want to do one more substitution. What was r? We said r was equal to x. So we're going to now do that so now we do the integration. Let's see, I can pull the 2 pi out. I get 0 to 2, x cubed plus x. I did a distributive property there. And now I'm going to get 2 pi times, let's see, 1/4 x to the 4th plus 1/2 x squared, evaluated from 2 to 0. And let me just do this here. Plugging in 0 is easy. I'll get 0. So what I get left is just 16 over 4 plus 4 over 2. So at the very end of the day, I get, let's see, that's 4 plus 2. I get times 6, and I get 12 pi, which is exactly the answer we got on the previous video when we used the washer method. So this video is probably worth giving another view to. The idea is the same. It's just when we're doing the area of the shell, which is what's going to go right inside of here, what we want to do is we want to do 2 pi r times that height. And so where do we get the height? Well, we got the height from reading it off from the picture. And where do we get the radius? We got the radius also from reading off that picture. So thank you for watching, and have a great day.